Hello everyone, today we are going to talk about hash functions, the functions that we are going to use in order to map from our data, our keys, to the indexes in the list. Let's first talk about some properties and details. This function should always give the same output with the same input. This should be deterministic. This should be fast, as it is computed many times during the lifetime of the hash table, and it should provide enough sparsity in order to distribute values in a balanced way. The hash function has two main components, the hash code function and the compression function. The hash code will provide a potentially huge integer value, and with the compression function we are going to constrain this value into a narrow range of values, in this case the positions in the list. Some remarks: we are not studying here how to design a good hash code that will provide a good sparsity, so we are going to use directly the hash function provided in all the hashable types in Python. We will talk about this hashable concept in a minute. As compression function, we are going to use the module operator, so the final hash function that we are going to use is the hash from Python module the number of buckets or the number of positions in the list. Let's talk about this hashable concept. In Python, an object is hashable if it has a hash method. For example, strings has a hash method, and if we call hash for a string, we obtain a huge integer value. With respect to the standard types in Python, not all of them are hashable. In fact, only immutable values are hashable. For example, integers, floats, strings, and so on. Mutable values are not hashable, for example, list, dictionary, and sets, because they can change during the execution of the program. Again, about this hashable concept, the user-defined classes are hashable by default. In this case, for computing the hash, it used the object ID, the ID that Python assigns to any object that is created. In this case, we have a class example with an X and Y. We create here two instances that are equal. They have the same, they contain the same information, but if we compute the hash code for each one is different, and in fact the equals method gives us a false. We can fix this behavior overwriting the hash and equals in order to be consistent. We can include, for example, here a new hash method considering X and Y to compute the hash. We can change the equals as well in order to consider X and Y. We can repeat this code, creating two instances, and now the hash and the equals are consistent. We are obtaining the same hash here. Thanks for watching, and see you in the next video.